Here at Desktop Metal and the creator of Fab Flow. And we're going to talk a little bit about eliminating barriers to 3D print shop success with software. So throughout this webinar, we're going to be digging into a lot of the common frustrations that additive manufacturing shop managers have and how software might be able to come in and help alleviate at least some of those frustrations. As always, if you have any questions throughout the webinar, feel free to drop them in the chat and we will take a look at those questions at the end of the webinar and answer some of those. So Rick, some of our viewers might not know this, but you were an early SolidWorks team member, helped kind of build that company up, that product. Came in here at Desktop Metal as a co-founder, so you have a breadth of experience in this additive manufacturing space. So you kind of took that experience and after working in this space for so long, created Fab Flow, after seeing some areas where you thought software could really help things. So can you talk a little bit about how you took all of that various experience and kind of turned it into what we see today as Fab Flow?
Sure, it was a combination of experience and talking to some of our existing customers. But if you think about it, right now in additive manufacturing, it's a really exciting time, right? Because we're right on the cusp of kind of going into this broad use of 3D printing or additive manufacturing in real industrial manufacturing. And that's actually the whole reason why we exist as a company, Desktop Metal. But at this particular moment in time, the vast majority of 3D printers that are being used right now are for rapid prototyping, right? So you have engineers asking a model shop for prototype parts. But there's no purpose-built software out there right now to support that particular workflow. And prototyping is a lot different than production. So prototyping, you need the ability to quickly order something with little interaction and very little time. You've got this very diverse set of parts that's constantly coming through the shop. And again, what happens is a lot of customers or shops will have to kind of do these kind of ad hoc solutions to support that workflow. And so instead, we've built a product specifically for that.
Awesome. So let's kind of dive into some of those problems that you found a little bit more. Okay. So I think sort of the two buckets that they fall into are the order management side of things. So figuring out, getting your part actually onto a printer and printing. And then the other side is tracking the job and tracking how those printers are working and the shop floor and all that kind of stuff. So can you talk a little bit more about these 2 points and kind of what problems fall underneath those?
Okay. So, basically you've taken like the whole process and kind of divided into these 2 big buckets, right? The kind of ordering on the upfront and then the tracking of things on the back side. During the ordering, right, I need the ability to, evaluate the model and see how much it should cost based on the amount of time and material, things of that nature. I need to validate the model and make sure that it is actually something that can be produced. And as it turns out, like I was saying before, there aren't a lot of existing software solutions to support that. And so what customers do is they have their kind of ad hoc solutions where it's kind of this combination of different tools that they'll be using, and then they have to move data back and forth between them. And then on the back end, again, people are using whatever tools that are available to them. And so they'll track things with desktop software that allows them to sort of see what's going on, but maybe not in a way that the rest of the team can benefit from.
Awesome. So it seems like there's a lot of different pieces to this puzzle, a lot of different frustrations that people run into. So I kind of want to try and tackle those one by one.
Okay.
As a reminder, if you're watching live, have any questions that come up throughout as we go into the software, anything about that, feel free to drop them in the chat section and we'll get to them at the end of the webinar. So Rick, let's start with the quoting piece. So somebody submits their part, wants to get a number as far as how much it's going to cost them to print to see if it's even feasible. So what is hard about quoting right now for additive manufacturing shops, and how does Fab Flow help actually solve that?
Okay, so 95% of the shops out there, let's just pick that number, but the vast majority of them are, again, using these kind of ad hoc solutions. And so what they'll do is they'll bring up that model that they've received from their internal customer into a 3D viewer or maybe the slicing software so they can look at it, make an estimate on the amount of material that will be consumed, how much time it'll spend on the machine, but then they've got to manually extract whatever the relevant numbers are and then put them into another piece of software, typically a spreadsheet, where they've set up their formulas for what the time and cost calculation will end up being, and then they'll generate the numbers and then they'll take that and plug it into a PDF file that they eventually mail back. And so the problem is you've inserted a person into the process, so it's to manually run software. Even worse, they're responsible for transferring information back and forth between the different applications, which makes the process not only slower, but more error prone. And so what we wanted to do instead is actually not only provide automated tools for the different steps, but fully integrate them, right? So this whole notion of manually moving information back and forth goes away. So if we step into the application, I kind of just show you very quickly. Okay, so like I was saying before, we have the ability to provide, in this hypothetical shop, stainless steel parts, but you'll also notice that we have plastic parts, but we're desktop metal. And one of the things I forgot to mention in the beginning is we've actually designed Fab Flow to be print technology agnostic. It doesn't matter whether you're using our hardware, EOS, 3D Systems, Stratasys, the system is actually designed to work equally well with all of those. And so in this particular case, I'm actually going to select stainless steel. Now what's great about this is when I select the type of part I want the shop to fabricate for me, the system springs into action and it does validation of the model, which I'll talk about in a couple of minutes, but it also generates an instant price quote. So again, I don't have to fire up the slicer manual, I don't have to pull numbers and put them into a spreadsheet, I get a number immediately. And what's wonderful about this is the way that we go about doing it, because we're grabbing information not only about the geometry of the part, but some printability, some printing parameters, and also things like, let me just expand this for a second, we even allow the shop manager to take into account things like what are the faces, right, that might be in contact with supports. We provide a rough estimate on the volume of material that's going to actually be used as support geometry. And these are values that can be plugged into formulas that are built into the system for the shop manager. And that gives the shop manager this ability to calculate an instant price quote. And even with things like options. So I can say, you know what, maybe we want to smooth the part by throwing it in a tumbler. And when I do that, you can see that the price updates to reflect that in real time without a person getting involved.
Awesome. So moving on to another struggle, model validation.
Yes.
So I imagine this can be kind of a big struggle before you even get to the point of being able to give an accurate quote on a model. So what makes model validation hard right now for additive manufacturing shops?
The thing that's really hard about it is it's a manual process. So again, the shop manager, when they're bringing up that model and the different pieces of software, not only are they looking at how big it is and the amount of material and so on, but they're also looking at the geometry to find out are there particular pieces of geometry that are going to cause problems from a printability standpoint. You know, are there walls that are too thin, or is the part too tall and skinny, and things like that. And rather than, again, having that be a manual process, we've provided automated tools to evaluate the model up front. And so in this particular case, you can see that we have 5 different things that we've told the system, well, for stainless steel parts, these are the things I want you to look at. Thin walls, trapped voids inside of the part. Are there trapped supports inside of the part that we can't get out? Are there small gaps between surfaces that might fuse together depending on the process? And then is the part too big to fit on the particular machine? If we actually step out and bring up the settings, one of the things that you'll notice is we have this library of different print issues that you can ask the system to look for, and then you just tell it which are the ones that are relevant to the particular part that I'm looking at right now. And then the system will, so it'll look at those and ignore these others. And so when I turn that on, right, again, we have the thin wall and the trap voids. I'll turn it on with the legend, and you can see we have this disc shape here inside this hole, right, that represents a thin wall. It's really easy when it's a very, very big, obvious thing, but it's the subtle ones where the value of this really comes into play.
Awesome. And I assume that's something that can be customized across different machinery that you have in your shop.
Different machines, different processes. You have you actually hear me use the word control a lot. And the whole idea is for the shop manager and the team to feel confident that they can deliver quality parts on time. They want control of the process. And Fab Flow has been designed to provide that.
Awesome. So it seems like the model validation piece kind of goes hand in hand with the communication back to the customer, because you have these problems, going back to your customer and saying you need to fix these problems is another struggle that a lot of people have. So can you talk a little bit about how people do that now and what Fab Flow's solution to that is?
Great point. Yeah, so me as the design engineer, I submit the model to the system. It tells me I have these printability issues. I've got two things I can do. One is I can go back and fix the model on my own, right, and then submit a new model, or I might want to have a dialogue with the shop, like you just mentioned. And so with this communication tool, right, I have the ability to turn on the printability issues, right? And what people normally do when they're communicating back and forth with the shop is they're sending emails. And maybe they'll take a screenshot and they'll mark up the screenshot and send it, and they'll kind of go back and forth that way. Well, rather than doing that, why don't we just mark up the same 3D model that we're sharing with the shop? So I'm going to create a new comment here, and I'll tell the system I want to do it on this 3D snapshot. I'll add text, I'll say something like, needs to be thicker, and we'll circle the problem geometry. And you can add more information here if you'd like. And you can create these comments not only on specific printability issues, but design communication as well. Maybe you want to do something like, let's add a comment that says, fill at this edge. Okay, save. And the great thing about this is we have this very, very compelling and clear way, right, to annotate our model, right, for design communication. And here I have some other notes that I've created previously on this particular model, and it's just a great way, right, to capture that information, that conversation.
Okay, awesome. So it seems like, in addition to helping manage customer communication, Fab Flow actually helps keep track of all those different versions that end up getting uploaded. When you go back and need a redesign, there's new version 1, version 2, version 3, and Fab Flow actually has a solution to help manage all of that.
Absolutely. Because when you think about the versions, right, there's kind of two different reasons we're going to have multiple versions of the model. One is kind of just a normal part of my design iteration process, right? So as I make modifications to the design over time, I'll be requesting additional prototypes, or the shop will ask me to make changes. I'll make that change and the shop wants to see them, like we have here in this particular case where there's some issues with the model. So let's do this. Let's upload a new version of this file. And I'm going to tell the system this is an updated version of the model that we're looking at right now. So you see the two models superimposed on one another, but the other thing that you'll see is the system's actually created a version 1.5, and this is really compelling. So when I select on that, what you're going to see happen is the system has determined where has material been removed, and that's shown in red, and then where has material been added, and that's shown in green. And this is a great way for the shop to validate, okay, the model has been updated or changed in such a way that it's going to be more printable, right, based on the suggestions that I've made to my customer. So as an example, right, we added a comment here about filleting the model, right, and we can actually see, the material has been added, in that intermediate representation, and then the final version of the part.
Awesome. Now moving on from the order management side to the job tracking side, how does Fab Flow help shop managers kind of track a job, after it's been ordered throughout the entire process of maybe many pieces of equipment, sub-equipment, subsystems throughout a shop.
So let's talk about like the equipment, right, that we might have in the shop. So let's actually go to setup for a second. And I'm going to go to printers and materials. And in our hypothetical shop, right, I have my desktop metal studio printer for prototyping metal parts. But remember, in the parts type list, I had the ability to print plastic parts as well, standard and heat resistant. Well, that's because I have a Fortis 450 in my shop. And again, we've designed this product to be fully print technology agnostic. So when I say add printer, what you'll see is we have a built-in database that is quite extensive. We have the latest update of the product. We're going to have printers from 40 different manufacturers, just over 325 printers, and I think there's going to be almost 3,200 materials represented in this database. So when we say that, you know, this is a product that's being designed to work equally well with products from any company, we really mean it. So, you know, as an example, let's look. We have a Fortis 250 or a Fortis 250 in our shop, but we can see again various machines from all the different manufacturers. Let's add this one from 3D Systems to our shop. And you can give the printer a name, a location. You can see that we know what materials are available on that particular machine. But you know what? You might have only a subset of those materials available in your shop. And so you can actually specify that subset. You even have the ability, remember before we had the system check to make sure the part wasn't too big? Well, we know what the build volume is, and you can even make it smaller if you wanted to for this particular printer, and it'll check against those numbers that you enter. Okay.
Awesome. So now that you've got your printers kind of all set up, how does Fab Flow help manage, call it the flow through the shop, of all these different parts? You know, say you have a scale of hundreds of parts coming into your prototyping shop. How do you Fab Flow help manage all those different parts throughout the actual production process?
Right. So, and you know, you mentioned the word flow. That's kind of the namesake of the product. And so this is what we're looking at right now, are the flows that represent the underlying process in the shop. So we start off by identifying what are the resources that exist in the shop. And so, you know, we have the printers like you saw a moment ago, but then we also have the other pieces of equipment that are used during the fabrication process within our shop. You know, with our studio system, we have our debinders and our furnaces, but there's other pieces of equipment too that are kind of more, that are kind of standard in many shops. Things like tumblers and paint booths and sandblasters and the like, or I have a washing station to remove the soluble supports on the Stratasys machines. So again, I can identify all those different resources that we have in our shop, but what makes it really compelling is when we tie them together with these flows. Because now I can say, for the different part types that we create in our shop, these are the steps and the resources that we use to actually produce those various parts. And now we can see, you know, which resources might be used by a lot of different processes, as an example.
Awesome. So I imagine having this kind of bird's eye view of your shop also must help communication between all the different people that are running these machines.
Yes, definitely. I was mentioned before, a lot of times shops will have kind of this ad hoc solution of whatever software tools they might have available, right? Like spreadsheets are really common. And so you might track where are the different jobs in the shop in a spreadsheet, right? But if I have a spreadsheet on my desktop, other people on the team can't see that. The great thing about these flows and the application is this is a single view that's available to everybody within the shop. And so I have this single truth of everything that's going on right now.
Awesome. And then I imagine this sort of view helps in other ways too, like being able to see sort of bottlenecks and seeing what the capacity of your shop is, things like that?
Absolutely. So you'll notice that we have this nice clear view of the shop, right? The resources, how they're all used. But then we actually have these badges in yellow, and the badges actually indicate where are the different jobs, how many parts are being processed on any particular device within the shop at this moment in time. And then what you were saying a moment ago about bottlenecks, we can see that what parts are kind of in queue are waiting to be processed, right? And if we have a large number of parts in queue in a particular step, okay, that might be a potential bottleneck that we need to start paying some attention to.
Awesome. Great. So before we get to questions, and feel free to add those while we're talking, I wanted to ask you just to kind of summarize the key takeaways that shop managers should have after watching, and taking a look at this software. Sort of what superpowers is this software going to be able to give to additive manufacturing shops?
I think it's basically going to give you, as a shop manager and the team that you're working with, the ability to be more efficient and more effective at your job. And again, I mentioned the word control before, right? The shop manager, they're experts in their job. They know how to best, produce the parts in a timely manner with the right quality, because they've done this for years. And so what we've been striving for at Fab Flow is to make the product versatile enough that they can capture their expertise, capture their process in this tool. And so not only does it allow them to capture their process in the flows I just demonstrated a moment ago, but it also provides this kind of overarching, this comprehensive set of tools, right, to fulfill each step in that overall process. Everything from the ordering, which includes the quoting, the model validation, to submitting the jobs to the shop and then tracking the jobs as they run through. And not only providing those tools, but just as important, the level of integration. So I'm not manually and in an error-prone way trying to move data or information back and forth.
Awesome. And then lastly, where can people go to actually get their hands on this software and try it out?
Right. So go to desktopmetal.com/FabFlow, and you'll be able to basically gain access to the product right from there. There's two different versions of it, standard and free. The free version, believe it or not, has the functionality that I've demonstrated and more. And so it's a great way to kind of just test drive the product and see if it'll fit, your particular needs.
Awesome. So we'll get started with some questions from the audience. So one question, the quotation you showed, what is that? Is that a production cost or a price for the customer, including like all the costs of the shop plus a profit margin on top of that?
So if we go back to the screen for just a second, when I select on one of the flows, all right, again, not only can I encompass or capture all the steps that make up that flow, well, you'll see I have a costing and a print issue tab. When I click on costing, I was mentioning before, I have the ability to take everything into account, the supports and all the steps involved. And if you look over here, we have a sample model with a bunch of measurements taken off of it, but we also have the ability to specify things like self-supporting angle, if the part's going to be shelled out, what the infill percentage of material is going to be, and all those numbers are now available to me in what I kind of refer to as a spreadsheet optimized for 3D printing. And the wonderful thing about this is we have the formulas predetermined for you, and we've broken it out so I can see how my costs, so I can see what my final cost is for this sample part as I kind of work through my costing model, but I can actually see, well, how much of that cost is associated with pre-processing, material cost, machine time, post-processing costs. Again, I can basically make this as simple or as complex as I want. Any values I care about, right, I type a quantity for. Anything I don't, I leave as a 0. And you were asking about things like, can I include a margin? And the answer is yes. So all those tools are built right in, and even with the quoted price, the automatically generated price, the shop manager still has the opportunity after the fact to go in and make an adjustment to that as well.
Awesome. So another question we have here, can you add/configure your own printers and your own materials for those printers?
Absolutely. So we're continually adding new printers and materials to the database, but under the Add Printer User Interface, I have a plus sign here that gives me the ability to add my own printers, and same thing for materials.
Awesome. Couple more here. So what if, so this is a cloud-based software.
Yes.
So what if someone can't run on the cloud? How does that kind of impact the Fab Flow world?
So at the moment, it is only a cloud-based solution. We're beginning work on what we're calling the enterprise version of the product, and one of the options that will be available in that is the ability to run off the cloud as a local cloud or on a local server. So my aspiration is to try and get that done by the end of the year or soon after.
Great. And then how about like file safety, data integrity, data safety, that stuff like that? People are uploading these files, it's proprietary, things like that. How do you manage that?
Really important, right? Your intellectual property is super, super important, and we recognize that. So a couple different things. We do something called encryption at rest and encryption at transit, so the data is protected when it's being communicated back and forth to our servers, and when it's saved on disk, it's also encrypted there. In the total unlikely event someone were to hack our site and get at your files, they can't actually access the data because, again, it's been encrypted and they don't have the keys. And to verify that or validate, the effectiveness of the work that we've done, we do something called penetration testing, where we actually have an external company come in, and basically there are these people that are called white hat hackers, right? They're not white hats because they're the good guys, not the bad guys. And so they actually try to hack the website to identify vulnerabilities. So we have that done on a quarterly basis to make sure that if there are any vulnerabilities, we know about them, we fix them to protect your data.
Another question we have here, so does the software communicate with printers directly, or is it still an interface that a human controls in between the two?
So a human will actually, you advance parts through the process to keep track of things, whether you're advancing things from to or from a printer or to another piece of equipment like a tumbler or something like that. What we're going to be doing with the enterprise version is we're going to be building in APIs or programming interfaces so that eventually we can talk to other software systems and equipment somewhere down the road.
Awesome. Great. Well, I think that is all we have from a question side of things. So just a reminder, if you're interested in learning more, trying out a free trial of the software with all of the features that we showed today, head on over to desktopmetal.com/fabflow, and there's a whole bunch more information there. There's some videos about it, some tutorials and things like that to help you get started. So thanks again, Rick. Thanks for joining us, and we look forward to seeing everybody again.
Thanks for the time.